So here we are for the today's session, experts dive guide into AIML. So first thing, artificial intelligence. The core principle behind machine learning is to learn from datasets and try to minimize error. The core principle for machine learning behind machine learning is to learn from dataset and minimize error, or maximize the probability or likelihood of prediction being true. Okay, so here are some computers program we can see doing like so here there are numbers of height datas, okay, x and y. Height data is x array, and these are that the conditions that a is greater than or equals to 50. It means above 150 centimeter and above 140 centimeter. How many? So who those are above, it's 1, and who those are less, this is printing 0. So here what we are doing, that seed so we are arranging or calculating how many students or people are above 1 or equals to 140 centimeter, or who are above or equals to 150 centimeter. We are calculating here just that. We can do this. This shows the learning ability of a computer. We don't have to say that much. Look here, threshold equals to 140. It means the base or the bar line which stands in which we will calculate. So x greater than equals to threshold, it means 140. And so what to print here, we have to print accuracy, how accurate or how many people are having. So in, let's say, 1.85 people, or in 185 people are having 140 centimeter, like no these let leave this. Here we see types of machine learning. So we learned that machine learning is the ability to learn from datasets and reduce the error or make the outcome probability true. Okay, here there are types of machine learning. So there are SURF, it means supervised, unsupervised, and reinforcement learning. Supervised learning, unsupervised learning. So what it means, in supervised learning we provide data label. Data sets are labeled. Okay, what the input we insert, like face recognition or the images of fruits, so we'll label them so that patterns can be detected and used to label new data sets. So by we label firstly, we input and label them, and then the machine understands that this is labeled this, like banana is labeled banana, so banana is long yellow, like this. So it understands when we label it. Okay, unsupervised learning, data aren't labeled and are sorted according to similarities or differences. So here what is done, like we gave 100 photos or images of different fruits, like say banana and mangoes, two we said. So here 70 we unlabeled them, and this is 30. So we aren't labeled them, but machine learning, what does it, that it sorted, it differentiated similar quality images, like a long shape yellow color and orange color and oval shape, same similarities to a different section. So it means here it is intra-class similarities. It means under the class similarities in this group, in this class, they have similarities corresponding to their other inputs, and here same intra-class similarities, but between them it is inter-class differentiation. Inter-class differentiation, it means this class doesn't match to this and this class doesn't match to this. Okay, so further we here datasets are labeled so that patterns can be detected and used to label new datasets. So here we do training, a learning algorithm, we training data, we labeled inputs or anything data, we do learning algorithm, then model is trained, we are testing, and then we are getting the accuracy. Okay, unsupervised learning, datasets are not labeled and sorted, it means grouped, we can say grouped to according to similarities or differences. No predefined classes, it means we won't label them, we won't group them. Okay, then this is this and this is this. The unsupervised model can be used to cluster data, group data, clusters where a class has high intra-class similarity, what we discussed, and low inter-class similarity. Small chain class A, let's say 10 people having same similarity, and section B of class A, similarities, qualities, they have class A, they have similar qualities, and class B has their similar qualities, but they are not have qualities meeting to each other. It means inter-class differences, okay, or no inter-class similarities, low inter-class similarities. Okay, limitations of machine learning. So limitations of machine learning, what are the limitations? So amount of data at this point, at the point we intensively give data to machine learning, it won't be able to increase its performance after the point of time. It settles, the performance of machine learning algorithm becomes constant even by giving more and more data. But in deep learning, how much the data we give it becomes more and more accurate, its performance increases more and more. Here we understand, let's say here it's written that first important limitation, high dimensional data. ML algorithms are not useful for a large number of inputs and outputs. Okay, so what we see here. And second important limitation is that feature extraction. We have to tell the computer what are features it should look for. It means when we give a photo of a person, okay, photo of person, so we in ML algorithm, in ML training, we have to tell the computer that we want their eye recognition or face recognition or their skin color. Okay, we have to tell them. Selection of good features become essential, and we have to select what feature we should want. Object recognition, handwriting recognition, and anything we would input. What is deep learning? Deep learning it is very famous nowadays. ChatGPT, okay, we've learned about machine learning. Now we'll learn about deep learning and we'll compare. Okay, so ChatGPT, Facebook's deep face can detect faces. iPhone's face recognition that can differentiate between a dead person owning its mobile won't unlock if a person dies and he's the owner of. If a person's face unlocks his phone, but in case he dies, the face recognition is so accurate and intelligent that it won't unlock if the person is dead and the camera is placed to his face. So this extensive accuracy comes by deep learning. Anything in this era, 2025, from 2023 we are having ChatGPT, Google AI. Okay, from 24 actually we are having Google AI, Gemini, and so on. They are all based on that are much faster are all based on deep learning. Google Lens that can predict and show results, can point the uh, products where they are selling, Snapchats, filters, okay, many filters, or Amazon's actually Amazon's mini TV that can recommend movies, YouTube's algorithm that what you watch, it will feed it in your, I mean, it becomes your feed. So artificial intelligence is this, the big box direction of, so an engineer of making machines and programs intelligent. Okay, what is machine learning? So ability to learn without being explicitly programmed. What it means that we don't have to hard code the machine for that. We just have to do input, inputting, giving images, and will want to specify what we want, like eyes colors, face recognition, or length of face, or anything. We can specify the computer and it will learn from itself and give output. But in deep learning, it, when we put our face data, it will blow up with the outputs. It will give possible outputs by him itself. We don't have to say that do this, make the facial recognition or eyes color recognition, anything. Here we understand that the raw data without labeling we do, deep learning is capable of learning to focus on the right features by themselves. It independently it works and focus on right features. It thinks what are the right features and gives output by its intelligence. Deep learning is one of the only methods by which we can overcome the challenges of feature extraction. We don't have to specify that this feature we want, anything. Deep networks are drawing into proper labeling, okay. Deep learning models are capable of learning to focus on the right features by themselves. Deep learning uses neural networks. So what are neural networks? Deep learning models mimics our brain function. It learns from experience. So our brain learns from experience, we learn from experience. So what does deep learning uses? Neural network, that artificial neural network which learns from experience. So deep learning. Now the question comes, how deep learning mimics the functionality of brain. So it uses the concept of artificial neurons that functions in a similar manner as biological neurons. Therefore we can say that deep learning is a subfield of machine learning. We can say that deep learning is a subfield of machine learning that concerned with algorithms and inspired by the structure of functions of brain called neural network, artificial neural network. Deep learning is a subset of machine learning that is concerned with algorithms and inspired by a structure and functions of brain called artificial neural networks. Then deep learning automatically finds out the features. Okay, so based on artificial neural networks, ANN, re-engineering of human brain. So here you see, this is a normal neuron, the human brain cell. Okay, so it is neuron, this part is axon. Axon is used to transmit signals to the other cells. Cell body sums all the inputs. What inputs comes from here, it sums it all. Then receives signals from other neuron. So the copy of this like here, and it will receive from here, it calculation done in here, then cell nuclear, and then shares the information from here, dendrites, axon. Or for better understanding of how ANN do this, artificial neural network do this, here we are, dendrites, cell body and axon. It receives, it calculates and it shares. Here inputs are given, aggregates it, artificial neural network, artificial neuron, you can say artificial neuron. What it does, it sums the input here, aggregates it, applies various transformations and functions and provides an output to us. What is the difference between biological neural network and artificial neural network? Neuron, artificial neuron, perceptron. Oh, this is the main thing, perceptron. This is the main thing. New network of neurons, network of artificial neurons. Okay. Dendrites, and here what is this? Connection lines are used to receive inputs, connection lines. Okay. Inputs are summed in the cell using the axon. It is passed on to the next biological neuron. Receives multiple inputs, aggregates it, okay, transforms and function and provides an output. Nothing that complex. Function of neurons. Neurons learn how to convert input signals into corresponding output signals. Learns automatic image recognition. If the picture resembles prior cat images the neuron have seen before, it will label it cat. Before. So here's an example. Neurons are having multiple hidden layers. You understand? Just it have, like in a brain cell we have only 3 layers, only one layer, like receiving and sending. In between we have only one layer, but in deep learning we have 3 layers. Okay. Face recognition using deep networks. So there are many layers between them. Receiving layer, input, output, and there are 3 layers. There are also 3 actual layers. 2 layers, but in human cell we have only one layer, that is cell itself. So this is all for today's 10 to 12 session. Thank you.